Okay. This unit has, the last couple of units we've had only one chapter per unit out of the book. What the district's decided is they're going to use actually, they're going to use two different chapters since they're so closely linked together to put into one unit. So basically that's why we went from the expressions chapter, chapter 7, and we're moving right into chapter 8 without taking a test. Okay, because it's very fast, but we're going to go ahead and they are linked together. So the first one is chapter 7 is on expressions. Chapter 8 is on equations. So now we're going to start seeing two expressions, right? Or I should say one with an equal sign, a sentence with an equal sign there. Okay, so that's what we're dealing with starting today. So we're just kind of picking up where you left off in 5th and 6th grade when it came to solving equations. Today we're going to talk about solving equations with rational coefficients. Okay, so if you don't know what that is, we do know what coefficients are. If you're talking about rational numbers, okay, it's been a while since we've talked about that, but let me just kind of cut to the chase. Today we're talking about equations that have coefficients that are fractions or decimals. Okay, that's what we're talking about. So you're going to find that solving them is very similar to solving equations in elementary school. However, I'm going to show you guys the traditional way, and then actually in some problems I'll show you a quicker way. All right, so we'll get to that eventually, but first vocab, so green on the left, notes on the right. Our very first word is solution. Everyone? Solution. All right, so when you're talking about a variable, here's what a solution is. It's a value for the variable that makes an equation true. A value for the variable that makes an equation true. All right, so for example, if you have an equation, it's a nice little simple one-step equation, m plus 7 equals 15, then the solution is m equals 8. M equals 8. Okay, so that's an example of a solution. All right, what they're looking for. Okay, here we go. Next word is inverse operation. Everyone? Inverse operation. All right, and I think I've used that name a few times in here, and I'm sure you heard it in elementary school. Here's what an inverse operation is. It's an operation that undoes another, such as addition and subtraction. Those are inverse operations of each other. An operation that undoes another. Okay, that's what your book calls it. There's a lot of different definitions for that, but that's what your book says. Here's what I just want you to write an example. Oops. If you have an addition sign, the inverse is subtraction. You could actually put it a double arrow. If you had subtraction, the inverse is addition. If you have a multiplication sign or multiplication problem, the inverse would be division, or vice versa. If you have a division problem, the inverse is multiplication. Okay, and then equivalent equations. Everyone? Equivalent equations. You probably know what that is just by reading it, right? This is two or more equations with the same solution. Two or more equations with the same solution. So, two simple little bitty equations. 2x equals 6 is an equivalent equation to 2 equals x minus 1. What's the solution to both, guys?
3.
X equals 3, right? That's what makes them equivalent expressions. Okay. So 2 times 3 is 6, or 2 is equal to 3 minus 1. Okay. Okay. Any questions? All right. Here we go. We're going to go ahead and start our example. So if you haven't done so, make sure your paper is out. Name, date, period up at the top, lesson number. Write down your actual lesson and your book page. All right, so grab your book if you haven't already done it. Flip over to 326 and 327. Okay. Let's take a look at page 326 and let's take a look at problem number 4. Okay. Now, what I'd like you guys to do is, and this is one of those that I'll let you write it down. I just want you to put your pencil down. Okay, I'll let you copy down the work and the answer here in a second, the work and the solution. Okay, number 4 in your book says this. Well, let me state this, okay? If I have a problem that looks like this, 4x equals 12. Now, we all know what the answer is, but if you were showing your work properly, here's what you would do. Because x is being multiplied with 4, we need to get the x by itself. So you do the inverse. You would divide by 4. Whatever you do to one side of the equation, you do to the other. The 4s, when you do the inverse, the whole reason why we're doing the inverse is because it eliminates it. All right, 4 divided by 4 is 1, and we know that 1x is the same as x, so that's why we do that. So it just gives us x. On the other side of the equal sign, 12 divided by 4 is 3. Okay, that's what we're going to be looking for. Okay, now, couple of things you need to know. Okay, even your teachers in the future, 8th grade teacher, 9th grade teacher, all the way through high school, when you balance equations, because that's what I just did, they are going to want you to show your work on both sides. And starting right now, your answer has to have the variable in it. The reason is well, there's 2 reasons. The minor reason actually is that you need to clarify that the solution, the 3, goes with the variable x, not with a y or not with a z. And actually in the future, you're going to be doing things that have 2 variables in the same problem. Okay? So you need to clarify what the solution is. And even more importantly, right now in this upcoming chapter, you need to clarify that it's equivalent, meaning it's equal to 3. There are other signs out there that is not an equal sign, that you're going to see it change. So you need to state that. Okay? So just a quick little review. All right, now I'm going to take it a half a step further. Number 4 in your book says 1/12 times n equals 12. Thank you, though. You don't have to pick up your pencil. All right, you're going to just watch this still. I'm going to do the exact same thing. If you take a look, n, like x is multiplied with 4, n is multiplied by 1/12. So here's what I'm going to do. I can divide by 1/12. Whatever I do to one side, I do to the other side. Just like over here, when you do the inverse, they're going to cancel out. So everything's exactly the same so far. Now here here's what we have. We have 12 divided by 1/12. Here's what we have. I'll write it over here. 12 divided by 1/12. If I was to solve that or simplify it, I'm putting 12 over 1. I am then doing keep, flip, change, KFC. I'm keeping the first fraction, I'm flipping the second fraction, and I'm changing the sign. The whole goal is to flip the second fraction, but I'm changing the sign to multiplication, which would give us 144 over 1, which ultimately our answer is n is equal to 144. Okay? The difference between this and this is the rational coefficient. And ultimately, though, what it is doing a little scratch paperwork on the side. Now, you can do it that way, because that's the traditional way. But let me show you a faster way. 1/12 n equals 12. Same problem. We know what the answer is. Now, I'm going to isolate the variable. Okay? I can divide by 1/12 just like I did up here, but listen, 1/12, okay, divided by 1/12. Well, I want to show you something. Actually, let's focus on this. 12 divided by 1/12, look what happens. Dividing by 1/12, we're ultimately multiplying by the reciprocal. So here's what we're going to do. Because of KFC, we're going to cut out a middle section of this problem. Instead of going over here and doing this, here's what I'm going to do. Instead of dividing by 1/12, dividing by 1/12 is the same as multiplying by 12 over 1. So here's what I'm going to do. I do that to that side. I multiply by the reciprocal, what's also called the multiplicative inverse. And then I do the same thing to the other side. These cancel, and we get n equals 144 over 1, which is 144. So instead of doing that, we're going to do that. A lot faster than all of this extra work here. Just by, all I did was I realized strategically, dividing by 1/12 is the same as multiplying by its reciprocal. So instead of doing all this and doing all that, multiply by the reciprocal on both sides, and we get our answer. Go straight to the answer. Okay, I'm going to let you ask questions in a second because we're going to write one step by step. But right now, just go ahead, do number 4. Write down, you can write down any of these, but all I'm requiring you to write down is this right here. Okay. Okay. All right, here's what we're going to do. So, step 1. And this is a very important step that some people, it's a simple mistake, but some people still make this mistake. Find your variable. That is so important. That's the side. The variable is not always on the left. Sometimes the variable is on the right. You need to find out which expression or which side of the equation your variable is on. Find your variable. Step 2, go to that side, and you're going to, in this case, I'm going to put quotations, quotes. I'm going to do the inverse, the opposite. Now, the reason why I put quotes around it is because remember, if I did it all as an inverse, I'm going to be doing a bunch of stuff like this up here, which is still works, it's just longer. But considering that it's a fraction, the inverse in this case, instead of dividing by -3/4, I am going to multiply by a -4/3. Step 3, you're going to do the same thing on the other side. I'm going to multiply by a -4/3. Be careful not to multiply by a +4/3. This is what people say. But Mr. Wilkins, it's negative on this side, so I'm going to do a positive. I'm doing the inverse over here. No, no, no. The inverse we're doing is the multiplication / division. You only do one inverse at a time. So when that is it, k is being multiplied with -3/4. That's why it's division. But of course, with KFC, we're doing the multiplication of the reciprocal. Okay? So here we go. Step 3, I wrote it over here. And step 4 is we are going to simplify. These cancel. We end up with k equals, and now here comes our math problem. It ends up being, I can't reduce, I can't cross reduce. So negative times a positive is a negative. And I get 4 times 2 is 8. 3 times 3 is 9. And our answer is k is equal to -8/9. Okay, guys, questions? All right, here's what I want you guys to try. Try out problem 24. 24. All right, go. How many of you need more time? Okay. All right. Anyone need more time? Okay. So, 30 seconds. Listen, when you share, start with your solution, but I want to make sure that your neighbor, okay, your partner should work on both sides of the equation. All right. If not, make sure you remind them to do it on both sides, okay, of the equal side. All right. So, go ahead, 30 seconds, turn to your neighbor and share. Go.
I got r equals -56, 5/6.
I got this. You can reduce.
Okay, here we go. Just looking right now, just looking for a solution. What is a solution that's out there? See number 30. Five, 6. Okay. Agree, disagree. Okay. Anyone have something a little different that they'd like to share? Good. I spend a lot of time just explaining why we need to write a variable and an equal sign. We need to make sure we're watching for that. Okay, good job, Jade. All right.
Question. Does it matter which side you put? Like if you put r equals 5/6, right?
So before I go on to solve this, a quick question was, and it's a good question, does it matter which side the variable is and the number is? So listen carefully. Many would argue that the proper way to express your solution is definitely having the variable on the left side. Okay, that's kind of the proper way. I am actually, you know me, I'm picky on a lot of things. That one I'm not going to be picky about, but be aware that you will have teachers that are extremely picky about that. An equal sign means balance. It means that this side is the same as this side. So me saying this side's the same as this side, saying that these two things are exactly the same. Well, this is saying the same thing, right? So that's why I'm not too picky about it, but I could understand proper form would be written like this in a lot of ways. So just be aware of that. Okay. So the short answer to the long one is this year I'm kind of open to that. It's okay, but just be aware that next year and your following years it might change depending on your teacher. Okay. All right, here we go. Number 24. Let's see if you guys are right. Here's our variable. Okay. Those of you that went to the left side first and did by 36/25, hopefully that's no one, but if you did, then you need to start boxing in your variable. That's what I have a lot of my students do, because that helps you identify where the variable is. Okay, so I have r multiplied with a negative 5/6. I'm going to go ahead, I could divide by negative 5/6, but instead I'm going to multiply by its reciprocal, negative 6/5. I'm going to do the same thing to the other side. And these cancel out, so I end up with r, I have it on the right, is equal to, and now hopefully none of you guys multiplied that and then reduce at the end, because you can reduce right now. 25 and 5, I can divide both by 5. This becomes a 1 and that becomes a 5. Divide both of these by 6, that becomes a 1 and that becomes a 6. I have a negative times a negative, which is going to give me a positive solution. Then I have a 1 times 5 is 5, and 1 times 6 is 6. And there we go. And again, if you write it in the proper way, r equals 5/6. Okay, questions on that? Okay, let's take a look at another type of problem. Okay, let's go all the way to problem number 30. Problem number 30. Okay? So, they actually, even though this problem does not have, I guess you could say it is, it's not a fraction coefficient or a decimal coefficient, okay? This looks a little different. So for number 30, okay, we have, it says, solve each equation, check your solution. Okay, it says 42 equals 4x plus 3x. Now, listen carefully. Before you solve any equation, solving means to find a solution, right? First, you should always, and this is what we'll call step star, you should always simplify expressions, like last chapter, when needed. Okay? Now, a lot of them won't be needed. They'll already be, the expression will already be simplified. However, remember, simplified expression means there's no parentheses and there's no like terms. The issue is those are like terms on that, in that expression there. Remember, this is an expression and that's an expression. So what I need to do is simplify the expressions first. In this case, they're like terms. I just add the coefficients, right? And so 4x plus 3x is 7x. And I rewrite my problem. And now, I'll just say, we'll just call this step 1, I guess. And that is, we're just going to keep it simple right now and just say solve. Just by using the exact same steps we just used. So once an expression is done, solve. Now, most of us can see what the solution is. I still want you, for this chapter, okay, even for this lesson, I want you to write your work. So I have x times 7, so if it's multiplying by 7, I'm going to do the inverse operation, divide by 7, do it on both sides, and I end up with x is equal to 6. Now, it does say check your solution. Okay, what it means to check your solution, and you don't have to write this down right now. Here's what it means. Plug your solution back into the problem for x. That's what that's talking about. So they want to know, is 42 equal to 24 plus 18? Yes, it is. So our solution is right. Okay. So if you want to check your solution, that's what you're doing. Now, here's what I'm going to say. This is our very first equation homework, all right? I gave you enough problems for you not to have to check your solutions. However, in this class, if you start struggling with solving equations, I will have you start doing these, either as a class or as individuals, because this, you can always find out if your answer is right by just plugging it back in to the equation to find out. Okay, so just kind of keep that in mind. All right, but for today, I won't require you to do that. All right. All right. Any questions on those two steps? All right, here's the one I want you guys to try. Try out problem 34. 34. Okay, go. All right. How many of you are still working on that? Okay. Bless you. All right, checking in again. How many of you still need some more time? Okay, 30 seconds, then I'll have you guys share. Again, those of you that are done, just move on to some other problems in that section. Okay. All right, so again, when you guys share, two things: solution and make sure that they're showing work on both sides. It's really important. All right, so go ahead and turn to your neighbors. 30 seconds. Share. Go.
What'd you get? I don't know if this is right, but I got n equals 7.6 permutation. I don't really know how I solved it. I just did negative 5 minus 18. Yeah, I did it over 8 for like 23%.
Okay. Okay, so problem 34 was m divided by negative 3 equals negative 5 minus 18. All right, so what you should have done is that obviously is simplified, but this is not, right? This here is a subtraction problem that has like terms. They're both constants. So if I go to solve this, m divided by negative 3 is equal to, and then I have negative 5 minus 18. They're both negatives. I add them together and I get a negative 23. Now at this point, I want to make sure that you guys are aware. The lesson today is called, it is not called equations or solving equations with fractions in it. Okay, that's not what it's called. It is called solving equations with rational coefficients. There is no coefficient here. So I'm hoping, I haven't even looked at any of your papers, but I know this is a common mistake. Do not start flipping things and doing reciprocals and everything on this. This is a basic division problem. Yes, it's expressed as a fraction, but it's a division problem. Okay, m is being divided by negative 3. So instead of dividing, I'm going to do the inverse. I'm going to multiply by negative 3. Here and here. Those cancel. We end up with m is equal to, well, those are both negative. Negative times a negative is a positive. 23 times 3, right? Well, that's 9 and 6. So m, okay, is equal to 69. Positive 69. Okay, questions on that one? Okay. All right, last type of problem, okay, that you're going to see on tonight's homework, the main skills, is problem number 10. Okay, here we go. Problem number 10, let's close read this. A forest preserve rents for $22.50 per hour. Corey has $90 to spend. Write and solve an equation to find out how many hours he can rent a canoe. Okay, so we talked about this the other day. All right, just briefly. I want to say it was in our POD, but I'm going to go ahead and I'm going to do it again, and we'll get more into this. But I have a way to help you guys write equation for those of you that struggle with it a little bit. Okay, it is called a bar diagram. And I think the other day we may have written just an expression. Today we're going to write an equation using a bar diagram. Okay, now just like when we talked about bar diagrams with percents, this represents the whole bar. Okay, now here's what you need to realize. This bar basically is representing almost like an equal sign. And what that means is remember, an equation has two expressions. One here and one here. And here's what we know. We know that they're both equal to each other. Okay? So what that means is we're going to list one of the expressions on top and one on the bottom, but they are both going to be equal to each other because it is represented by the same bar. Now here's what I'm going to do. It says a forest preserve rents canoes for $22.50 per hour. Here's what I'm going to do. I'm going to break this bar up into, the price for 1 hour, $22.50. But do we know, are they renting it for 1 hour? No. They rent it for, actually, we don't know how many hours. What we do know is that every hour, and you don't have to do the whole thing, I'll just put ... every hour is $22.50. Here's what we do know. This whole bar represents the total. Look at that second sentence. Corey has $90 to spend. That's the total amount that he has to spend on this canoe. 90 is going to go up top. That's where our total is. Now here's the thing. The bottom is $22.50. Now anytime in your bar you have repetition, that is signifying, of course, a unit rate, basically. So what we're talking here is $22.50 per hour. The problem is we don't know how many of these. We're going to let that be represented. So $22.50 rents at 2 hours. Are you going to multiply $22.50 by 2? If he rents at 3 hours, you're going to multiply $22.50 by 3, right? Well, we don't know how many hours, so that we're going to multiply this with an unknown, which is just a variable. $22.50x. If you want to write it as $22.50h, I'm okay with that. H for hours. You'll see that a lot. Now here's what we know. What I said at the very beginning of this problem. This is equal to that. So if I write that down, so if we're talking about steps, step 1 is draw your bar diagram and label your two expressions. Step 2 is convert this to an equation. It's $22.50 times x equals 90. Step 3, solve. So it does say write and solve an equation, right? So they want to see the equation in your work. And then we need to solve it. So x is being multiplied with 2250, so we're going to divide by 2250 here and on the other side. Those cancel. X is equal to whatever 90 divided by 2250 is. So some of you guys, 90 divided by 2250 equals x is equal to 4. Step 4 is, let's put well, I already gave it away. Let's put our units on there, right? And in this case, we read the question, write and solve an equation to find out how many hours he can rent a canoe. 4 hours. Okay. Now, this is a word problem, so you don't necessarily have to write the x. You use it to solve it, but the complete answer is 4 hours. Okay? Okay, guys. Rational coefficients with equations.